Hello everyone, welcome to Math 107. This is the first video that I'm making for Math 107. I like to make short videos to not lose your attention. But with that being said, anytime you need clarification on anything, please don't hesitate to reach out. I can make more videos, we can talk more. Some of this material, especially this first section, I think is really challenging. So I want you to get the support that you need. In order to do this section, it's possible that the most important part of it is to know how to go from a percent to a decimal or a decimal to a percent. Keep in mind, when you go from a percent to a decimal, what you're really doing is moving the decimal place 2 places to the left, which, by the way, is the equivalent of dividing something by 100. Percent actually is a term, comes from Latin, that means per 100, cent, like century, centurion, all that sort of stuff. So if I want to convert 25% and I want to make it a decimal, I have 2 choices. I can either divide that by 100, which is a totally great thing to do, or I can simply take the decimal, which, by the way, if there's not a decimal in a number, it is understood to be at the end of that number, and I take that and I move it 2 places to the left. That means that I get 0.25. And 25% makes sense that it would be 0.25. As a fraction, if I was going to simplify 25 over 100, I would get 1/4. And that also makes sense. You should be able to take any percent, make it a decimal or a fraction. You should also be able to take any fraction or decimal and make it into a percent. If I told you that I had a pie and I ate 25% of that pie, it would make sense that I ate 1/4 of that pie, that would not be hard for me to do. I could easily eat 25% or 1/4 of a pie. Let's suppose that you wanted to convert from a decimal to a percent. When you want to convert from a decimal to a percent, instead of moving 2 places to the left, you are going to move 2 places to the right. Also, if you wanted to convert mathematically, instead of dividing by 100, you would be multiplying by 100. So if I want to convert 0.006 to a percent, I have a choice. I can either take the decimal and move it 2 places to the right, which would be 0.6%, or I could take that number, 0.006, and I could multiply that by 100. Guess what? I would get the same thing, 0.6%. Sometimes they don't turn out like you think they do. For example, if I have the number 2 and I want to make that a percent, that'd be 200%. I would move the decimal 2 places to the right, and that totally makes sense. If you double something, you have 200% of something. Let's talk about the percent of a number. Suppose I want something like 12% of 60. If I want 12% of 60, the first step is to take this percent and make it into a decimal. Remember how I do that? 2 places to the left. Then all you have to do is multiply by your number. So if I want 12% of 60, I take 0.12 times 60, and that would give me 7.2. The other part of the homework, and there, I apologize because this homework is so dense. There are so many different concepts in this particular homework assignment. We have a lot of learning outcomes, and this is just a huge assignment. I think the other assignments will be perhaps a little less varied in everything that you need to know. Percent increase and decrease. Now, I have done examples in the homework where I use the terminology of the book. What I always think about as percent increase and decrease is this. It's the new amount minus the old amount divided by the old amount. And if this particular formula works for you, I think that's great. This particular formula right here, if you just kept it at new minus old divided by old, that would give you the decimal. We don't want the decimal. We want the percent. So we're going to take that and we're going to multiply it by 100. Try that formula for the times in the homework where it asks you for a percent increase and decrease. I think you'll be happy. It works pretty well. Let's talk about the other major part of this particular homework. It is called dimensional analysis. Usually when we talk about dimensional analysis, you would talk about this as conversions. Conversions are really nothing more than multiplying by 1. But they're not your typical ones that you see. They are fancy ones. So for example, you're usually probably used to like getting a common denominator. So you could take a fraction and say multiply it by 2 over 2. Ooh, what did I do? That's bizarre. Ignore me. 2 over 2. And if I have 2 divided by 2, that is equal to 1 because it's something over the same exact thing. Did you know that I can also create ones that don't look the same? So for example, I know that 12 inches is equal to 1 foot. If I wanted to create a number 1, as long as I have those particular dimensions or units, I could say that 12 inches divided by 1 foot is equal to 1. 1 foot divided by 12 inches is also equal to 1. We're not used to thinking about that, but in dimensional analysis or doing conversions, it's so helpful. So when you're reading my answer key, which by the way is posted in Canvas for this homework, or you're looking at the videos, keep that in mind. This is nothing more than multiplying by 1. So let's go ahead and look at this particular example. It's similar to number 9 in your homework. It says we want to put a 5-inch layer of topsoil on a garden, and the garden is 19 feet by 25 feet. So basically, it's asking how much topsoil we're going to need. So we've got a garden 19 feet by 25 feet, and we're going to top it with some soil. So what we need to know is, well, how much soil are we going to need in this particular case? This is a good application problem. What it says is we're going to put a 5-inch thick layer on top. Well, you know what? I can't put just a 5 for the height of this because that's in inches and my other dimensions are feet. So what am I going to do? That's correct. I'm going to say 5 inches, and I'm going to create a new number using dimensional analysis. When you use dimensional analysis, keep in mind that you're always trying to get things to cancel out. So in other words, up here, inches is in the top. I have to have inches in the bottom because I want my inches to cancel out. How many inches? And I want to convert. These guys are in feet, so I want feet. So I know that 12 inches is 1 foot. So what I have here is 5/12. My inches cancel out, and I'm left with feet. So what I have is a particular box or prism that's 25 feet by 19 feet by 5/12 of a foot. Very ugly numbers, I'm not going to lie. Now, the thing that we need to focus on is they want to know, the question is, how many cubic yards will you need? How many cubic yards will we need? Sorry, I'm going to try and change that color. There we go. So what we're going to need is, let's talk about this. First, we need the volume. How many cubic yards do we need? I don't know. Let's figure out how many cubic feet we are going to have first. So the volume of any object is the length times the width times the height. So I've got the length, 19 feet, times the width, 25 feet, times the height, 5/12 of a foot. So what I'm going to put 1 over these guys. What I'm going to do is I'm going to multiply all of that, maybe if I can find a calculator, and I multiply the numerators all through. 19 times 25 times 5. So I get 2,375 twelfths. And what is my unit? It's a volume. It's feet cubed, which, by the way, is feet times feet times feet. I got feet cubed because I multiplied this many feet 3 times. However, a cubic yard is a totally different animal. It's a totally different kind of unit. So what I'm going to do is I'm going to take this volume, my cubic feet, 2,375 twelfths. And instead of calling it cubic feet, I'm going to do something a little weird. I'm going to call it feet times feet times feet, because I need to do a conversion. And you need to be really careful when you do conversions. Feet and cubic feet, totally different animals. So what I'm going to do is I'm going to try and get rid of feet. And what I want is yards. So I'm going to go from feet to yards. 3 feet is 1 yard. And if I do that, then that means that this cancels with just one of these. So guess what? I have to do it 3 times. And if I do that, this foot will cancel with this foot, this will cancel with this. Notice what I have remaining is yards times yards times yards. I've got cubic yards. I can multiply straight across. So in the top, it's 2,375 times 1 times 1 times 1. In the bottom, I'm going to take 12 times 3 times 3 times 3 and get 324. What I have left is yards times yards times yards, which is yards cubed. that is a very quick rundown of this particular section. Please let me know what questions you have. Have a great day.